Today I thought we'd talk about debugging. It's a really interesting topic for software people. How do you find bugs when you've got bugs? Well, it's very interesting to me because the tooling and the technology available for debugging has gotten considerably better. But it's not clear to me debugging's gotten any better. So let me explain what I mean by that. So when I started, compilations would take about 24 hours, and so debugging was a very different kind of operation. You did a lot of desk checking, you really worked things through, and you learned how to put into your code a lot of sort of indicators of things that are going on. So when things went wrong, then you could see, look at the indicators, know where you were and all that. And that came to a sort of a culmination for me a bit later in my career when I was working with microprocessors. At that point in time, there was no debuggers for those. So there was no way to sort of single step these things or anything like that. So you had to do all of your debugging based on sort of evidence that the processor left around. And so it was difficult to do that. And we were a small company, and there was two of us doing most of the software, and one of the people was an excellent at this. But he wrote very convoluted code. And he got moved off to a separate project, and I was supposed to fix this, and we didn't have enough performance on this particular piece of code. And so I spent quite a lot of time kind of debugging that, trying to find out what was going on, putting in logs, all the things you do, now which are considerably easier, but things that you do to sort of leave traces and see where things are and where you're spending your time. And finally, I gave up. I had to go to my boss and say, "Look, I can't do this. I need to take another approach." And what I did was I re-implemented the code, and it was not a huge problem. So what we did is we built a little monitoring system, and then did that, and everything started working just by taking a look at it. It was just too hard to debug otherwise. So the first thing I want to say is sometimes debugging is really a matter of saying, look, this code is not understandable the way it is, and we need to understand it better first. Sometimes that means rewriting. Now that can be dangerous unless you have what? Tests. Unless you have enough tests to keep you knowing. That's kind of what refactoring is about. Although I'm not talking about necessarily changing the design, but sort of changing the implementation to better understand the design. So this turns into refactoring, and that's what we notice. We notice that the better the software developers, the more they rewrote their code, the more they made it clear about what it was doing. And we noticed that ourselves, that we had this phenomena of having code which didn't work right, rewriting the code and having it work. Without really, in many cases, without really quite understanding what we had done differently. It wasn't worth going in and understanding what we did differently. It wasn't worth the time and effort to do that. So debugging to me is really an opportunity to understand your code better, right? Now, with the growth of test-driven development as a way of development, test first, even a stronger statement about that, then debugging becomes much less of a time sink. Because I've spent days debugging issues and all of that, and all of us have that spend any time with software, and it's very inefficient use of our time. So to reduce that, we'd like it to really spend that debugging time with the gnarly problems, not the simpler problems that unit testing and that level of testing can really find for us. And so it takes us back to good design and all those kinds of things that we know about how to write better software. So the other side of it is that what I found oftentimes is that many bugs show up as a result of an early conception of an object or something that had some responsibilities, and those responsibilities grew too much. Now this is an old argument. It's encapsulation. You've heard this from many people all the time. But for me, it's more real because it's come out of my experience. It's what I really experienced. Is I just noticed that if I had a complicated class that did a bunch of things, that if I separated it out into 3 or 4 classes that did each one doing less things, that the code would be more reliable. It would work better. In fact, one can argue one can argue that the real value of object-oriented programming is in fact for maintenance. It's because debugging is easier. You can constrain your fixes. You know you're not going to go outside of boundaries. And with the addition of the testing, good coverage at unit testing, that makes the systems very, very robust. Now, that doesn't solve the problems of the higher level design being inadequate or the architecture that's picked not being up to the challenge and all that. So we still have those issues, but they've raised up in complexity level quite a lot. The abstraction level is considerably higher. And so the tools we need to use there are a little different. There we might, because we have complex systems, we have the emergent behavior, then we might really have to use testing, and experimentation isn't the only way to do it. We have to try things and see what they do. See, try this, try that, try that. And that's what we used to do that as well. We'd try different paths through the code and look at the log files and see all the evidence that was laid around that. And so that hasn't changed. It's just the level that we're doing that has gone up. So you need to sort of say, are you using the right tools at the right level? If you're debugging way down in the code, you shouldn't be having lots of log files and laying all that out. In fact, I've watched people putting a lot of code like that into their systems. And then they go, why are the systems so slow? You're spending all your time writing out all these logging files and all of that if you don't have a good mechanism to turn it off. But even turning it off can still add a lot of overhead, because you got to keep checking, is it on, is it on, is it on? And what happens then is that you have less system performance for very little gain. That the gain that you're spending a lot of CPU cycles gathering information that is rarely relevant. Now, people argue that when it is relevant, you really need it. And I would say yes, but look at the data you have about that. Is it easier when a problem comes up to put some stuff in and figure out what it is? Usually you have some idea what it is. Or is it better than maybe to have some high-level, very high-level stuff, not much overhead, and gives you enough context setting so now when a bug does show up, you can reconstruct that. And that's an art. Figuring out how to do that's an art. But what we want to do is we want to reduce the time we're spent single-stepping. I mean, that's what we used to do. I'm not sure people do that much anymore, but single-stepping the code, looking at it at that level, because it's such an incredibly bad use of both people time and computer time. So think about your abstraction when you're debugging. Think about the levels of abstraction and what low-level testing you can do to make those kind of bugs less likely. And then how can you think about this system? What's the architecture? How are things hanging together? Because looking and reading and understanding the code will help you find those bugs almost more than any other technique. So there you go, some issues about debugging.